Today we're going to start talking about deductive reasoning. So far we've talked a lot about inductive reasoning, which was following patterns, projecting forward into the future based on those patterns. We were making educated guesses. Deductive reasoning is really the opposite of that, because we aren't going to be making educated guesses. Deductive reasoning is when we are going to take a very true statement, or more likely a series of true statements, and make very logical conclusions from those true statements. The classic example of this was actually by Aristotle. He wrote, "All men are mortal. Socrates is a man. Therefore, Socrates is mortal." He took two very true statements to draw a very logical conclusion. That is what deductive reasoning is all about. Two forms of deductive reasoning that we are going to study. One of them is called the law of detachment. This is drawing conclusions from one conditional statement. We're going to be given a true conditional statement. That means my hypothesis is true, my conclusion is true. Example, if a car is out of gas, then it will not start. That's a true conditional statement. We are then going to be given a new statement. The key here is it has to match the hypothesis of my original conditional, not my conclusion. So it must match the hypothesis for the law of detachment to provide a conclusion. Since the hypothesis is that a car is out of gas, and Sarah's car is out of gas, it matches my hypothesis of a true statement. Logically, I can then conclude, Q, her car will run out of gas. So again, just to kind of reiterate, if it matches my conclusion, I cannot draw any conclusion at all. There's no logic. So if I said, if a car is out of gas, then it will not start, Sarah's car will not start, that is not going to allow me to make a conclusion, because that does not meet the logic step of my hypothesis. That tells me it won't start. There's many reasons it might not start, only one of them being it's out of gas. So my second statement must match my original hypothesis, and that is the only way it can work. Otherwise, I can have no conclusion. Let's look at a few more examples for law of detachment. If a point is a midpoint of a segment, then it divides the segment into two congruent segments. We know that's true. They tell me that B is a midpoint of segment AC. That is part of my original hypothesis. It's a point that is a midpoint of a segment. Since that matches my hypothesis, I can make my conclusion. B divides segment AC into two congruent segments. Example 2. They tell me that if a point is a midpoint of a segment, then it divides the segment into two congruent segments. So again, same exact conditional. We know that's true. But then they provide for me a new statement. G is between A and Z. That doesn't match either my hypothesis or my conclusion. I can't draw any conclusion from this. This doesn't match. It's completely separate. I have no conclusion. That's just like saying if a point is a midpoint, then it divides a segment into two congruent segments, and then saying I like doors. That doesn't make any sense. It makes no sense with what we've been given as a true statement. There's no logical conclusion we can make. Example 3 is a slightly different kind. It kind of goes back to some that are a little trickier. If Blake goes to the beach, then he will wear sunscreen. That's a true statement. But then they tell me that Blake wears sunscreen. That doesn't match my hypothesis. It matches my conclusion. The only way for the law of detachment to work is to take a true statement and then start off with something that matches the hypothesis. Since this doesn't, I have no conclusion here either. So again, it must be one true conditional statement followed by a statement that matches your hypothesis for you to draw your conclusion. If it doesn't meet that exact criteria, there will be no conclusion. I want you to go ahead and try numbers 4 and 5 on your own. After you're done, unpause it to check your answers. So I've color-coded these for us to be able to go through and talk about it real quick. 3 points are non-collinear. They determine a plane. A, B, and C lie in a plane. None of those 3 statements match. There's no conclusion here. I can only make a conclusion if I was told the 3 points were non-collinear. In number 5, a student turns in a permission slip. They can go on the field trip. Mary turns in her permission slip. Logically, that matches my hypothesis. We can conclude that Mary can go on the field trip. Okay, in video 2, we're going to talk about not law of detachment, but something called the law of syllogism, which is when we are given multiple conditional statements, more than just one true statement, and how to follow the logic steps from one to the other.